Industrially, diethyl ether is prepared via the acid-catalyzed dehydration of ethanol. So if we take ethanol and we use some concentrated H2SO4, for example, we can produce diethyl ether. And 2 moles of ethanol will produce only 1 mole of diethyl ether. And there's also some water as a byproduct. So how does this work? We have ethanol, and it's being treated with concentrated H2SO4, so the acid in solution is hydronium ion. So there will be a proton transfer. Ethanol can pick up a proton from hydronium ion. So we draw the conjugate acid of ethanol, and then another molecule of ethanol can do an SN2 reaction. Remember that this will not undergo loss of a leaving group to do SN1 because we never form a primary carbocation. So because this alpha carbon is primary, we have to do SN2. So we'll have nucleophilic attack and simultaneous loss of a leaving group. Now this reaction will require heat because ethanol is not a very good nucleophile for an SN2 reaction. It's considered a weak nucleophile. So initially we get this, and we've also kicked out some water. And so then we just need to use ethanol or water to do a final proton transfer. It's much more likely to be ethanol because there'll be a lot more of that in solution. So that will produce the product, and it will generate some protonated ethanol. So we only needed a catalytic amount of acid because it was used and regenerated. This method is available to produce relatively simple symmetrical ethers. If you want to make an asymmetrical ether, you would need a different method